Hi guys, today we're going to learn scaling and rolling update of Kubernetes deployment. So let's start that now. So first create a deployment. So for that I can create a deployment YAML file first. So va deployment.yaml. Then I've added the content for this particular deployment. So in previous session I've explained this YAML file. Today we'll just brief this. So here we have four main contents, that is AKMS, API version, kind, metadata and spec. API version is always app/v1. Then kind is type of the Kubernetes resource you are going to create. Today I am going to create a deployment. Then as a metadata you can add name for this particular deployment, that's Nginx deployment. Then you can add specifications. So here replicas is nothing but number of pods in this particular deployment, that is 3. How you can select the pods for this particular deployment, that is using the selector. So we use labels for selecting the pods, and the label key is app and the value is the Nginx. Then we add pod template for this particular YAML file. Then all pods should have the labels called as app Nginx. And this is the pod specification. Generally we specify the container specification here. And the container name is Nginx, and image we use is Nginx latest, and the port, that is container port. So Nginx will run on 80 port. So let's save this particular YAML file. Then let's create the deployment using kubectl apply -f. F means file name, then the file name, that is deployment.yaml. So L is missed. So now Nginx deployment is created. You can run commands like kubectl get deployments. So you can see Nginx deployment is created and it has 3 pods. Also deployments will have the replica sets. In the YAML file we have mentioned the replica as 3. So we can run command like kubectl get replica set. So we'll get this particular replica set now. So when we create the deployment, indirectly we are creating the replica set also. Here replica set is nothing but group of standalone pods. So now let's see the scaling part. So let's check manual scaling first, then we will go for the auto scaling. For scaling we have the command kubectl scale deployment. So we are going to scale the deployment, and the deployment name, that is Nginx -deployment, then -- replicas. I'm going to scale it to 5. Here scaling is nothing but increasing or decreasing the number of pods, means number of replicas. That's why I'm going to add this particular flag now. So when I run Kubernetes scale command, internally Kubernetes will schedule the new pods. If I run kubectl get pods now, you can see 5 pods are running now. So using Kubernetes scale command, I can scale my deployment. Similarly, I can reduce the number of replicas. For example, I am going to give it 2. So now internally Kubernetes will terminate the additional pods. Now if I run kubectl get pods, we have only 2 pods now. So this is one method of scaling. Also I can modify the deployment YAML file, then I can run kubectl apply. So I will modify the replicas as 4. And if I save this file, and if I again run kubectl get pods, I have only 2 pods now. And now if I run kubectl apply, deployment is configured, means deployment is updated now. And if I run kubectl get pods now, I have 4 pods. So there are 2 ways in manual scaling. One is using kubectl scale command. Another one is directly mentioning the YAML file and apply that particular YAML file. Now let's see the auto scaling part. There are many types of auto scaling. First we will check the horizontal pod auto scaler. So for horizontal pod auto scaler or for HPA, I can run the command called as kubectl auto scale, then the deployment, then the deployment name, that is Nginx -deployment. Then I have to add a matrix here. Matrix is nothing but based on what auto scaling should happen. Matrix like CPU percentage, memory percentage, something like that. Here I am going to use --CPU percent, and CPU percentage I am going to add it as 50%. Then I have to provide minimum and maximum number of pods. So minimum I can give 2, and -maximum I can give 10. You can see horizontal pod autoscaler is created now. So when I run this command, if the CPU percentage is greater than 50%, Kubernetes will automatically scale up the number of pods. And it will scale up to the 10 pods because maximum pods is 10. Similarly, if the CPU percentage is less than 50%, Kubernetes will scale down the number of pods. It will scale down up to 2 pods because minimum number of pods is 2. You can get the HPA status using kubectl get HPA also. HPA is nothing but horizontal pods autoscale. Here you can see the details like the name of the autoscaler, then the reference, then the targets, then the minimum number of pods and maximum number of pods, then the replicas. Replicas here is 4. And autoscaling target is CPU percentage, that is 50%. So HPA details you can get using the command get HPA command. So this is HPA, horizontal pod autoscaler. Similarly, we have VPA, means vertical pod autoscaler. In HPA, we are going to increase the number of pods, and vertical means we are going to increase the resource of particular pods. For VPA, we can create separate YAML file, vpa.yaml. Here I have added the YAML file content. It will have AKMS. API version is different now. And the kind is a Kubernetes resource, that is VPA. In metadata, I have added the name of this particular VPA, that is Nginx VPA. In spec, I have mentioned the target reference. Here, target is nothing but the deployment, that is Nginx deployment. And I have added the update policy, that is update mode auto. Here in update mode, we have three choices. I can have a value off. Off means VPA only recommends the values, but it does not apply those values. Another choice is initial. When I mention initial here, VPA sets request only when the pod is created, and it won't update the resources while running the pods. And another choice is auto. Auto means it will automatically update the pod resources even when the pod is running. Here auto mode is dangerous because this will apply to the running pods also, and it might recreate the pods. This might result in a downtime of your application. Let's save this YAML file now. So that is about different auto scaling methods. We have HPA and VPA. Now let's check out the rolling updates in Kubernetes deployment. So here update means you are going to deploy the new version of your application. So now let's check out those application updates using the Kubernetes deployment. And one note here is, during the update, there should be no downtime. This can be achieved using the Kubernetes rolling updates. Here rolling generally means one pod at a time will be updated. So here new application version means new code and the new Docker image. So we are going to change the image now. So for that I have the command kubectl set image for deployment, and the deployment name is Nginx deployment. The next image will be Nginx equal to Nginx colon. I can give particular version here, for example 1.21. Then I can add hyphen record flag also. Then I can check the progress also here using kubectl rollout status and the deployment. The deployment is Nginx deployment. So you can see Nginx deployment is successfully rolled out. So when I run the rolled update, this is what happens internally. The first Kubernetes creates a new pods with the updated image. Then the old pods are gradually terminated. And the main thing is this transition ensures the zero downtime. I can check the history of this particular rolled out update also using kubectl rollout history command. Instead of status, I can just give history here. You can see this is the command I have executed earlier. So here by default Kubernetes updates only one pod at a time, but you can customize that using the YAML file. So let's see that now using the deployment YAML file. So here in deployment specification, I can add one content called as strategy. In strategy type is rolling update, and here I can modify the max surge and max unavailable pods. So max surge means maximum extra pods during the update, and max unavailable means maximum unavailable pods during the update. So this I can modify. By default it is 1, I can modify 2, 3, any number of pods. So let's save this now. So rolled update will ensure the smooth transition without the downtime of your application. Then you can roll back this particular update using the command kubectl rollout undo and the deployment slash Nginx deployment. So if I execute this particular command now, so this will revert my deployment to the previous version of my deployment. So if something is wrong in your new version of your application, then you can roll back your deployment using the kubectl rollout undo command. So by default undo will go to the previous version. And if you want to roll back your Kubernetes deployment to the particular version, then I can give the revision number also here. Using -2 revision and the revision number 2, 3 or any number. This number will get using the kubectl rollout history command that we have executed earlier. So that's it. Today we have learned about scaling of our deployments. There we have manually scaled first. Then in auto scaling we have learned about HPA and VPA. Then we have learned about rolled updates. Then we checked out about the rollback of our update also. That's it for today. Subscribe and check out other videos too.